Okay, so as we saw from the first part, how the molecules are formed, and so here's some examples of the different molecules. And what I wanted to explain here, these lines are representing covalent bonds. If you see pictures like this. Now, if you notice here, there are two lines connecting these two oxygen molecules. If you see two lines like this, it just means that instead of two electrons being shared, it's just more electrons were shared. And so if you remember with the hydrogen, it's one from each that are being shared, but with oxygen, it's actually two that are being shared in between them. If you see three lines instead, that means that it's a triple bond, and then with that one, it's 6 electrons that are being shared total. Okay, so with covalent bonding, there are actually two types. There are polar covalent bonds and then non-polar covalent bonds. So I want you to know here for the polar covalent bonds, this results from unequal sharing of electrons in covalent bonds, so between the different atoms. And know that water is a polar molecule, meaning that it's made from the polar covalent bonding. So what does that mean? Why is water a polar covalent bond? Because if one atom is larger than the other ones, or the other one, this causes that atom to attract more electrons towards itself. But hydrogens are smaller in the water molecule, they attract fewer electrons. So because this one the atom is much larger, it ends up giving it an unequal sharing of electrons. And so this is what this writing is saying here. In this water molecule, the oxygen's nucleus pulls electrons more strongly than the hydrogen's nuclei. Nuclei just means the plural of nucleus. And so water ends up being a polar covalent bond. Okay, so because it's a polar covalent bond, what happens is the oxygen's part of the water molecule ends up being more negative. Hydrogens are more positive because, again, oxygen attracted more electrons towards itself. So because of the charge differences, this attraction forms between separate water molecules. This attraction between the separate water molecules is called hydrogen bonding. Okay, so I always say this to students to remember. Remember that the polar covalent bond forms one water molecule. Okay, so that would be the bonds between the hydrogen and the oxygen going this way. But a hydrogen bond is between different water molecules, or the neighboring water molecules. And it's not just for water, but it's for other molecules that are made up of polar covalent bonding too. So the attraction between them also leads to hydrogen bonds if there's a hydrogen there. Okay, so chemical reactions occur when the chemical bonds either form or break. Okay, form or break. So we can make larger, bigger molecules or break them into smaller parts. And what it's saying here, what you start out with in a chemical reaction is called a reactant, and what you end up with is called a product. And so in this case, this one is breaking apart this molecule here, but it could go the opposite way as well. And so know that a synthesis reaction, it's the same thing as anabolism. Anabolism builds larger molecules. Decomposition reaction, catabolism. This one breaks apart. And this one builds. Don't worry about the other two. Just know the synthesis versus decomposition differences here. We'll talk about the other ones in another chapter. Okay, so then next, a little bit about acids and bases and salts. We'll see where that comes in. Acids and bases are made up of different atoms. And so what happens is when you put them in water, they actually separate from each other, the parts of the acid, but it also happens to the parts of the base. Okay, so the important thing here, know the pH scale. pH scale goes from 0 to 14, and we're seeing in the picture common substances with the different pHs. I want you to know that if the pH is 7, then it is neutral. It's not an acid or a base. This is the pH of water. Acids are less than 7, so that's what that symbol represents, and bases are greater than 7. I always see mistakes on this on tests. Students think it's the opposite way, so please, I'm just kind of warning you, study that. Acids less than 7, bases greater than 7. Oh, and also let me point this out. Acids have more hydrogen inside, but bases have more OH instead. OH refers to oxygen and hydrogen combined, and it's actually called a hydroxide. OH is hydroxide. Okay, but so know that acids have more hydrogen. Please write that down. Our blood's pH should be between this range. If it's not between this range, it will cause a lot of problems for our nervous system. So acidosis just means when the pH drops below that level. Alkalosis, or alkaline, means a base. Alkalosis means that when our blood becomes more basic, so it goes up. But thankfully, in our blood, we have these molecules called buffers. And they're only just molecules. And these buffers, they act as both an acid and a base, because they're able to give off hydrogens and also take up hydroxides, the other side to them. So know that buffers in our blood help to neutralize both acids and bases. So if something is wrong and your blood becomes too acidic, our buffers try to fix it. And the opposite is true as well.